I'm John, the author of Mathization. I updated the algorithm. It's slightly simpler. It uses just one loop now. And this is an example of the type of equation it can solve. I have 10 terms, and it's power of x. Those are difficult to solve equations, and there's like no algebraic solution except trial and error. And that's what this program does for algorithm, and but it's much faster. You can get it done in less than a second. What could take an hour or a couple hours, especially if the more terms it is, the longer that will take. So I have the type of equation. So enter the initial number of terms to use. You can use 1 to 10. So just put 3. I think this was the example I used originally. So enter. Enter the positive valued result of the expression, or 0 to quit. So I know the result is say 0.08 something, I think an 8. That's when x was equal to -2 for the first 3 terms. A was 5, 6, and 7. A was 5, B was 6, third term coefficient was 7, and there. So x was equal to 2, slightly over 2. Press a key and you can redo it in the loop. I made this for my ebook called Mathization, and I guess it's copyrighted, the book and algorithm. So, but I guess people can try it, if they need it. It'd be nice if you can get my book and make a donation. So one particular find with this algorithm is you can use it to find logarithms, because the logarithm is an exponent, the actual value. So say one term, and see, this result would be equivalent to the number of the logarithm. Say it's 10. Say the result is 10, and a, say that would be the base 10, and it should be 1, right? The exponent, yeah. How about enter the number of terms? 1 again. Try say 100 now, or 1,000, and say the base was 10. Of course, you can use any base you want, including E, 2.718, and there. So it's an interesting way to find logarithms, and it doesn't use any of the standard successive approximation formulas that zero in. This is more like I call it a fast numerical algorithm, FANA, and you can use it to solve difficult equations or logarithms of any base. So I'll try to show you the actual algorithm here now, and takes the number or the result of the expression, how many terms you want to use. It's up to 10 I have it set for, so that's probably more than enough. So x starts at a very low value, the exponent, and then it increments. TR and V, they make the result of the equation test value, temporary value, a positive value. Of course, I have it also set to go to a function to do that, and then return the temporary value. And it's the same, if it's more than a result, so that means temp's too high, so decrement x, will I have it by the increment here for the algorithm, and then increment equals increment divided by 10. Otherwise, x is x plus the increment, and then just a loop counter there. So it's a much simpler algorithm now. Try to put it here, right here. That's the whole algorithm. Besides the error checking or making positive values, it's only about 3 or 4 lines of code. Of course, the loop breaks when it's a very low value here, about a billion, I guess, billion. So, okay, thank you.